morning, good afternoon, and good evening, everybody. Yeah, everybody from the world. And I'm the Xiaowen, the coordinator of current series, Air Pollution and Human Health. I would like to welcome you all to join us. And last week, we had a lecture on exposure to air pollution mixture in an indigenous community in the heart of the oil sand from Professor Brooke. And today we are going to have the 7th lecture. Our honor speaker is Professor Guoxing. He's going to give a lecture on health impact of China's air pollution, prevention and control action plan. Professor Li is currently associate professor at the Department of Occupational and Environmental Health Sciences, School of Public Health, Peking University. He got his PhD degree at Peking University in 2011, and Professor Li's research interests include environmental epidemiology, air pollution and health, and climate change and health as well. He has published 83 papers and books already. So let's welcome Professor Li. I'm going to hand it over to you. Okay. After sharing.
So I can share the screen.
Sure.
Okay.
Okay.
Wait a minute.
Yeah.
Is it okay?
Yeah. We can see your slides.
Okay. Okay. Thank you. Thanks for the introduction, Professor Zheng. And hello, everybody. I'm Guoxing from Peking University. I'm very glad to have a chance to share our team's work here. Today, my topic is health impact of China's air pollution prevention and control action plan. My contents have 4 different parts. Firstly, I will have an introduction about the background of air pollution conditions and policies in China. Then I will share 2 researches about air pollution related health burden. As we know in China, because the China air pollution prevention and control action plan included 10 items. So we also call it Air 10 in Chinese, 大气10条. In this picture, it is very interesting, and this one showed the effects of Industrial Revolution on air quality in London. It is obvious that heavy smoke is from iron making covered most of sky. With the development of economy, the air quality become bad. So air pollution is not a newly emerged problem. It's a historical problem. Compared with water and soil pollution, we can notice that air pollution attracted more attention. What's the reason? Compared with water and soil pollution and an individual, we have to share similar with others. In Chinese, instead, 同呼吸共命运. So it is important for us to work together to make the air quality better. In 2015, the United Nations proposed 17 global goals. The 11th goal is sustainable cities and community. In schools, the content is bike, walk, or use public transportations to keep our cities air clean. In recent years, the adverse effects of air pollution, especially PM2.5, has attracted world attention. This figure showed the PM2.5 concentration in global level. In the upper part, PM2.5 concentration in North Africa and China are higher. However, when mineral dust and sea salt source PM2.5 were removed, the North Africa concentration decreased quickly. The eastern part of China concentration is still higher. This suggests that anthropogenic source is the major source for China's air pollution. When talking about PM2.5, we are concerned about the historical conditions in China. In the round rectangle, we notice that since 1990s, the concentration of PM2.5 is relatively higher. So in China, it is not a new emerged problem. It's a historical problem. Based on Breuer's study from 1990 to 2005, the ozone concentration showed an obvious increasing trend in eastern part of China. So, ozone has also become one primary threat for public health in China. 2 years ago, GBD published his report. This report showed that South and East China contributed 59% of the 42 million global deaths attributable to ambient PM2.5. Such results are mostly based on exposure response curve of developed countries. There is a gap of PM2.5 exposure between developed countries and China. As we know, the air pollution level in China is relatively higher compared with that in developed countries. So it is urgent to carry out more epidemiology studies to accurately evaluate the disease burden of air pollution in China. This slide showed the timeline of Chinese air pollution related policy. In 1987, Chinese government has established law on the prevention and control of atmospheric pollution. There are 3 revisions about the law. Before the second revision, the law is mostly about coal burning related pollution. In the second revision on the law, the total emission control of major air pollutants were considered, such as PM10, sulfur dioxide, nitrogen dioxide. In the third revision on the law, air quality is considered one important factor. In 2013, because of smoke days in January, China's air pollution prevention and control action plan was employed, and very clear aims were set for 3 heavy air pollution regions. And in 2018, to further improve the air quality, a 3-year plan on defending the blue sky was carried out. We look forward to the effects of this 3-year plan. The relationship between air pollution and health could be divided into short-term and long-term effects, and there is mixed effects between them. So, in the study about the relationship between air pollution and health, we should carefully consider about the short-term and long-term effects to avoid underestimating or overestimating the effects of air pollution. In our analysis, we also use another disease burden index to explore the effects of air pollution, years of life lost, YLL, compared with commonly used index mortality. The advantage of this index is obvious. On the one hand, it includes the mortality frequency information. On the other hand, it can provide age and gender-specific life loss information. So, compared with mortality, it can better comprehensively reflect more information. In phase 1, I would like to introduce our team's first work on the evaluation of PM2.5 adverse effects on health. This study was carried out in 2012. At that time, this study attracted many media attention. And this study provided the basis for our today's research. In this study, we evaluate both the health effect and economic loss of PM2.5 at the same time. In study, 4 cities were selected based on data availability. We selected 4 cities in China: Beijing, which is in Beijing-Tianjin-Hebei region; Xi'an, which is in Western region, one important city for One Belt, One Road; Guangzhou, which is in Pearl River Delta region; Shanghai, which is in Yangtze River Delta region. In most cities, the population size is more than 10 million. In this study, we explored both the excess mortality and economic loss. For example, in Beijing, the excess mortality is over 2,000, and the related economic burden is nearly 2 million Chinese yuan. We found nearly 2% of total mortality can attribute to PM2.5. Maybe you will be surprised. The health burden is smaller than that you imagine. I will explain this to you in the next slide. This study is carried in 7 years ago, so there is several obvious limitations for this for our first analysis. One, in study, we assume the exposure curve is linear. Secondly, as we know, the effects of PM2.5 can be divided into short-term effects and long-term effects. However, in study, we only considered about the short-term effects of PM2.5. So we could underestimate the effects of PM2.5. Thirdly, in study, we did not consider the effects of other air pollutants, such as sulfur dioxide or Ozone. After our report was released in January next year, smog days occurred in China. This animation shows the phenomenon at that time. It is obvious the visibility is very bad. So the public became concerned on the adverse effects of air pollution. Based on one Chinese study, the direct cost on health and transportation related with the heavy heat is 23 billion Chinese yuan. The price is very high. So in this year, the State Council of China published the Air Pollution Prevention and Control Action Plan. In this plan, 10 items were included, so we also call it Air 10. Item 8 is to establish the regional coordination mechanism and the integrated environmental management. And item 10 is clarify the responsibilities of the government, enterprise, and society. I think this item is very important. In my opinion, the status of this plan in China is like the Clean Air Act in the United States. Last year, we evaluated the health effect of air 10 in China. In this study, we selected 74 cities. These cities were selected on the basis of their geographical distribution, data availability, population size. They were the first to conduct regular monitoring ambient PM2.5 since 2012, as required by the central government. Additionally, the total population in these cities amounted to 0. billion in 2017, accounting for approximately 40% of China's population. 3 key regions for air pollution control defined by the State Council of China were also selected. The Beijing-Tianjin-Hebei region, the Yangtze River Delta region, the Pearl River region. These 3 regions are considered the most developed regions of China. Air pollution improvement target for these 3 regions has been highlighted in this plan. PM2 concentrations for the Beijing-Tianjin-Hebei region shall be lowered by 25%. The Yangtze River Delta region lowered by 20%, and the Pearl River Delta region lowered by 15% in 2017 compared with 2013. Additionally, the annual average of PM2.5 concentration in Beijing was set. The annual average concentration in Beijing shall be controlled below 16 micrograms per cubic meters in 2017. This figure showed that most of air pollutants was decreasing. However, ozone showed slightly higher in 2017 than that in 2013. Concentrations of PM2.5, PM10, sulfur dioxide, carbon monoxide decreased overall during the 5-year period. There are large reductions in PM2.5 concentration. which occurred in a nonlinear pattern, with a rapid reduction at first, followed by slower reduction. The average annual PM2.5 concentration in the 74 key cities was reduced from 72 micrograms per cubic meter to 47 microgram per cubic meter, a reduction of 33% in 2017 compared with 2013. The reduction in average annual PM2.5 concentration was 37% for the Beijing-Tianjin-Hebei region, 35% for the Yangtze River Delta region, and 26% for the Pearl River Delta region. Furthermore, the annual average PM2.5 concentration in Beijing was below 16 micrograms per cubic meter in 2017. These three regions and Beijing therefore achieved the target set out in the AirTag. The average annual reduction in PM10 concentration was 27.8% in the 74 key cities. The average annual sulfur dioxide concentration decreased from 14 microgram per cubic meter in 2013 to 17 micrograms per cubic meter in 2017 in the 74 key cities, a reduction of 54.1%. No significant change in nitrogen dioxide concentration was evident. The ozone concentration increased. In 2017, as a result of substantial improvement in air quality, there were 47,000 fewer deaths and 710,000 fewer years of life lost in the 74 key cities in China than that in 2013. From 2013 to 2017, there was a general decrease in the attributed numbers of deaths and years of life lost because of ambient PM2.5 exposure. In 2013, it is estimated that the health loss associated with PM2.5 in the 74 key cities in China included 420,000 premature deaths. In 2017, the estimate decreased to 365,000 premature deaths attributable to PM2.5 pollution. Exposure to ozone contributed to 49,000 premature deaths and 432,000 years of life lost in 2013 in the 74 key cities. This number increased to 56,000 deaths and 500,000 years of life lost in 2017. The number of avoid deaths and years of life lost attributed to air quality improvements in the Beijing, Tianjin, Hebei, Yangtze River Delta, and Pearl River Delta region are shown in this figure. In general, the avoided deaths and YLL increased from 2014 to 2017. There were 26,000 fewer deaths and 389,000 fewer years of life in the three key regions in 2017, which accounted for 55.5% of deaths and 5% of years of life lost in the 74 cities. In the discussion part one, we would have a comparison study between countries. On this December 4th, 1952, in the Great London, smog lasted for 5 days and led to around 3 to 4,000 people more deaths than usual. The graph shows the average smoke and sulfur dioxide levels for 12 London sites and the relationship with deaths recorded during the smoke period in December 1952. The peak in the number of deaths coincided with the peak in both smoke and sulfur dioxide pollution levels. Because of the Great London smoke accident, so the first Clean Air Act was introduced in 1956. This act aimed to control domestic source of smoke pollution by introducing smokeless zones. In these areas, smokeless fuels had to be burned. The Clean Air Act focused on reducing smoke pollution, but the measures taken actually helped to reduce sulfur dioxide levels at the same time. The Clean Air Act of 1968 brought in the basic principles for the use of tall chimneys for industry burning coals, liquid and gaseous fuels. In 1993, it's the last amendment of this act. The effects are obvious. From 1970 to 2010, total emission of black smoke, sulfur dioxide, carbon monoxide, and so on was significantly reduced. This suggested that the act the effect is very obvious. So we also have a comparison with United States. As we know, There also have a very big air pollution accident in the United States. So in 1963, the United States passed the Clean Air Act. This act was passed in 1963, but important major amendments were added to the original act in 1970 and 1990. This act implements a comprehensive program for reducing air pollution, focusing on the reduction of ambient and source-specific air pollution. The 1965 amendment was the first federal government's active role in clean air policy. But it was the Clean Air Act of 1970, which for the first time granted real power to the federal government instead of the states. The Clean Air Act was last amended in 1990. This amendment addressed environmental issues like acid rain, toxic pollutants, areas are still not at regulation standards, and so on. In the United States, the Federal Environmental Protection Agency is ultimately responsible for establishing standards and enforcing the Clean Air Act. This slide showed the air pollutant change in the United States from 1990 to 2017. It is obvious that both PM 2.5 and ozone decreased in the past years. However, we found that the PM 2.5 decrease speed is higher than that of ozone. So it is ozone pollution is become one primary hazard not only to China but also to developed countries. In March 2011, EP issued the second prospective report, which looked at the results of Clean Air Act from 1990 to 2020. According to this study, the central benefit estimate exceeds cost by a factor of more than 30 to 1. In 2020, the Clean Air Act amendments will prevent over 230,000 premature deaths. About 85% of the economic benefits are attributable to the reduction in premature mortality associated with reduction in ambient particulate matter. So as for United States, they think that it is a good investment. In our study, we also consider that other factors might affect the result. One of the important factors is the meteorological factor. In our study, we do not get the daily mean wind speed, the data, the number and intensity of winter time in Washington's data. So we could not remove the effects observed on the reduction of air pollution. In 2019, one study in China evaluated the impacts of meteorological change from 2013 to 2017 on PM2.5 mass reduction in 3 key regions. They found, as for Beijing-Tianjin-Hebei region, 5% reduction of PM2.5 reduction could attribute to meteorology. As for Yangtze River Delta region, nearly 7%. However, as for the Pearl River Delta region, the effect on meteorological factors is very small. This study suggested that air pollution control methods play important roles in the reduction of air pollution in China in the past 5 years. Policy is another factor. In Beijing-Tianjin-Hebei region, Beijing actively sought to coordinate air pollution control measures with the surrounding areas. At the end of 2013, Beijing was asked to lead the establishment of the mechanism for coordinated prevention and control of air pollution in Beijing, Tianjin, Hebei, and surrounding areas, with the support of China State Council. In 2017, the former Ministry of Environmental Protection identified that 28 cities in Beijing, Tianjin, Hebei, and surrounding areas as air pollution transportation channel. Through collaborative planning, unified standard, and joint emergency response, information sharing, the air quality of the whole region has significantly improved. We think monitoring technique is another factor. Beijing started to build the air quality monitoring system in the 1980s. By 2013, 35 ambient air quality monitoring stations, which can monitor 6 major pollutants such as PM2.5 and ozone, had been established across Beijing. In 2016, combining advanced technologies, a new generation of integrated air quality monitoring network was established. This figure shows a high density of PM2.5 monitoring network in Beijing, which deployed over 1,000 PM2.5 sensors throughout the whole city. This is very helpful to accurately identify high emission areas and periods. This figure is environmental Kuznets curve. This curve was first advanced by economist Simon Kuznets in the 1950s and 60s. And since the 1980s, the environmental Kuznets curve has become a standard feature in the technical literature of environmental policy. This curve shows the relationship between economic growth and environmental consumption and degradation. and we can see the relationship between them is inverse U-shape. Yeah, we can have further discussion about this curve, whether it's okay to use in this area. After our study was finished, this work was appreciated by the director of US HEI, Daniel. He think our work is important for continued learning and improvement in tackling this important issue. Another comment in frontiers in ecology and the environment is that this is the encouraging results at a good time. Some media also reported this study, such as China Daily. Nowadays, more and more court studies have appeared. We believe that in near future, we can evaluate the disease burden based on China court study. As for public health, intervention study is very important. We need more evidence in this field to help public protect themselves in group and individual level. At the same time, we also should notice the newly emerged challenge of the adverse effects of ozone on public health. That's all. Thank you for your attention. Okay.
Okay, thank you, Professor Lee, just for your wonderful presentation. And
thank you.
Well, we are opening for questions. If you have questions, you can type your questions on the chat box on the bottom of the panel. Well, I'm very happy to see that China has made measurable progress in improving the air quality, and we can see the disease burden is going down. And actually, China's air pollution, we have the comparable the level with the India, but one of your slides show that the disease burden is still going higher in the India. So, well, we can see that the Chinese government actually they took a lot of the efforts on the air pollution control action. Well, I have a question. Can you just go back to the slide, the 13 slide, I guess.
Wait a minute.
30, I guess.
30.
Right, it's about the meteorological effect of the
okay.
2.5. All right, yeah. Well, for the whole river delta region, we cannot from your study, we cannot see the effect of the meteorological impact on the PM 2.5 reduction. Is that correct?
This paper is nearly published in 2019, because in this field there are many different voices, and we adopted the most newly published papers in their study, because they used okay, wait a minute. In study, they compared the meteorological trend nearly at least 30 years. So I think it is better easy. It is easy to accept it, because as we know, there's one study in Tsinghua University. This study's results showed that nearly 30% of PM2.5 reduction should attribute to meteorological factors. But as we know, it's very complex. I have consulted some meteorological experts in this field. They think it is very difficult to accurately evaluate the effects of meteorological factors. So I think maybe there is a big range, not an exact number.
Okay, but we still well, I mean, the meteorological factors like the temperature, the humidity, they are also also important when we evaluate the air pollutants on the human health, because sometimes they have modification on the effect. Well, is there any questions from the audience? Well, actually, I have another question. Could you please go back to page 20? I guess it's 20.
20 written.
Oh yes, yeah, you show us the 6 major air pollutants. Well, I'm quite cannot get that. You had minor, isn't it minor? The concentration of air pollutant, your y-x, you had minors like 30 or 40 for what's that? Is that PM 2.5 or? I mean the three lines below to 0. How could that the minors? Just don't know how.
Oh yeah. Well, what's the meaning of minors?
Right, it is the concentration of it's a percentage.
Yeah, it's a percent. Yeah. This is the results in 2017 compared with 2013. So because the air pollution level in 2013, the air pollution level is relatively higher, and in 2017, the air pollution level is relatively lower. So the relative change of air pollutants, some air pollutants is negative. It's a comparison between 2017 to that in 2013. Relative change.
You're right. It's the temporal change from the 2013 to 2017. Right.
2013 to 2017. Yes.
Okay. Okay. Thank you. Is there any questions? Now, if not, we would like to thank Professor Lee for your excellent presentation. And I would also like to remind you that the next Wednesday, we're going to have another lecture on air pollution and cardiorespiratory disease and cancer from Professor Caroline Lodge. And so I will see you next Wednesday. Okay, thank you. Thank you all, your audience. Bye.
Bye.